Welcome everyone. Thank you for joining us for the last webinar in our Hidden Factory series. My name is Agatha Walker and I'm the Marketing Manager at InVMA. I'm here to introduce you to our keynote speakers. First, we have John Hill, Chief Operating Officer at InVMA. John worked as an executive consultant, program manager, and engineer. He has a successful history of developing innovative business strategies and delivering large-scale IT-enabled change. John is an expert on using live data from connected devices to improve client profitability. We also have Alan Findlay, the Managing Director of Haley 24/7 Engineering Services Limited, trading as Drive Management Services, which he founded in 2004. DMS provide engineering reliability services to all types of industries, specializing in condition-based monitoring and root cause analysis. Alan is a time-served mechanical engineer with 40 years experience. He has vast experience in gearboxes and power transmission. John and Alan will be happy to answer your questions, so I would like to encourage you to type your questions into the question box in your control panel. They will be answered at the end of the session. Now, it's over to you, John.
Hello and welcome to InVMA's Hidden Factory webinar series. My name is John Hill. I'm the Chief Operating Officer of InVMA. And before I introduce you to our guest speaker today, I'd like to just explain to you a little bit about InVMA and who we are, the background to the webinar series, and also what you can expect to get value from the series as you look through and probably look at the other webinars that we have on offer. So first of all, about InVMA. Our purpose is to connect the physical and digital worlds to transform industry. And we do this by using technology, solving problems, and driving change. What makes us unique is that we have a deep sector expertise and track record in the industrial market. We have an end-to-end industrial transformation capability from strategy consultancy through to control systems integration. We have an extensive ecosystem of partners. They include PTC with their ThingWorx and Vuforia Studio, Microsoft Azure, ARM for connectivity, Dell for gateways and hardware. The other thing that makes us unique is our flexible products and services. We have our Asset Minder product, which enables you to rapidly get to value in your digital transformation or smart factory implementation. And our services range from a simple discovery workshop to expose you to the new technologies that may impact your business, through to a strategy workshop with your senior leadership team to identify where the best bets are to place with the new digital technologies. A design and implementation workshop, which looks at how and what's the best ways of implementing in your specific situation, followed by our more traditional application development and system integration services. And of course, once you have done the implementation, our support package and service level agreements to help maintain the savings and investments that you've made. Why did we decide on raising and starting this webinar series? Well, bluntly, it's because digital transformation is happening now. Recent study by PwC showed that 90% of industrial companies are investing in digital factories. 70% of companies consider digital manufacturing at the top of their operation strategy agenda, according to McKinsey. And indeed, in the United States, the National Association of Manufacturers have made the statement that industrial companies need to capitalize on digital technologies to defend and advance their competitive advantage. Indeed, the World Economic Forum have found that those companies, the lighthouse implementations, as they call them, yield a huge impact. And they've reported double-digit KPI improvement in areas from factory output increase to productivity, to OEE, to product cost, time to market reduction. And indeed, the Standard & Poor's have noted that failure to act and make digital implementations over the next 10 years, half of the people in the Standard & Poor's 500 firms will be displaced. Most companies fail to move to this stage of scale and capture value at scale. And McKinsey in 2018 identified that in large factories, there are up to 8 digital transformation related pilots running in each one of those factories. but only 25% of those succeeded. 75% of those failed to go on to deliver any continuing value. And that's why we set up the webinar series. What we're trying to do is, through our demonstrations of maybe the technology and our approaches, but more importantly, presentations from our partners and our customers who are going through this process or have delivered on these processes right now, will prove valuable to our other potential customers and current customers. In the next 25 minutes or so, we're going to really discuss what are the advantages of predictive remote monitoring, and then bring it alive with some use cases from one of our customers and good friend, Alan Findlay from Drive Management Services. Before we started, though, we just wanted to give some view of the agenda. So really what we were trying to do is to show the value of using data to prevent failure and the consequential damage and costs that causes. So we're going to start off by exploring failure and the different types of maintenance that there are. We're going to explore why the balance is moving from the reactive and planned to predictive and prescriptive maintenance. We're going to understand the new technologies that make this possible, introduce you to Drive Management Services Machine Guard powered by Asset Minder product, and then use some real case studies and savings from DMS with some of their customers. And then we're going to have a look at current developments and future developments, and then we're going to conclude and open up to questions. So most of you will know this already, but just to recap for those that don't, there are four main types of maintenance. Reactive maintenance, you wait till it breaks and then you fix it. Preventative maintenance, a bit like car service, where you go through a checklist and based on hours usage or indeed just time, you go and do a set of tasks that are there to extend the life of the product and of the asset and to stop it breaking down. Predictive maintenance is what we're going to use today, where you use sensors and measurement to understand the likelihood of a failure occurring and then taking action to address that. And then prescriptive maintenance, which is much like predictive, whereas using the data to actually tell you not only when something's going to go wrong, but what is going to go wrong and how you're going to fix it. Case for condition-based monitoring or predictive maintenance is that really for some manufacturers, and when you look across, a 10% reduction in maintenance costs is equivalent to about a 40% increase in sales on the factory P&L. Think about that for a minute. Every pound that you save on maintenance, every pound that you save on downtime goes straight to your bottom line. And the extra revenue that you would have to get hold of that is significant. Throughout the world, the best overall equipment effectiveness, which includes, as you know, availability, is 97%. World class is 83%. The average is 66%, and in some countries, particularly the UK, it's down at 50%. Another way of looking at it, this means nearly a third of investment in assets is wasted. So all that kit that is just lying there that is wasted, it's not being productive. And a lot of this waste is driven from poor quality or as we say, unplanned downtime. However, machines give you plenty of warning if they're in distress. Their vibration signatures can change, their oil quality can change, their temperatures can change, pressures behave differently, and indeed the current even that they draw will change. So if we knew, and this is the key point here, is if we compare two cycles of like a normal reactive cycle and a predictive cycle. If we look at a reactive cycle, then the asset develops some abnormal health condition, and generally an andon light comes on or there's some indication on HMI. And then an operator notifies maintenance through message, for example, or a works order. They open the work order and then the maintenance person gets dispatched to the asset. They look at the sensors, the signatures, the history. They look at the machine overall. They review the asset and then they make some remediation based on that and then they verify it. In that time, you've had the downtime. Now with predictive, what happens is we get up front some sort of automated anomaly detection with alert and notification. So the maintenance teams are already assessed that even before it's starting to get into true distress, that there's something to consider there. You can have a look online, review the sensors, signature and the history, and that leads to shorter debugging and troubleshooting time, and then obviously shorter remediation time. You literally go out to the machine with some sense of what it is that you need to address before you get there. And that significantly reduces the amount of unplanned downtime through the use of predictive. But if its case is so obvious, and we believe it really is obvious, what's been stopping us? Well, it's really split into 4 categories as we see it. The first one is cost. To put fixed condition-based monitoring system in puts a lot of hardware and installation cost. Also, when you're specifying machines in the early days, the project engineer will be looking at the CapEx project and what they're trying to do to get inside budget, potentially at the detriment of the overall lifetime operating costs. Condition monitoring as well traditionally has also involved an engineer, some specialist, etc., coming to site to come and sit and attach temporary and handheld equipment against the asset to give advice, particularly on the larger assets, about estimated time to failure and also the types of maintenance regime that would be required. And that is, involves a highly qualified person to be in a van travelling to come and see you, so it's cost. The other one is access, is to just get physical access to the systems and machines, even with the handheld items is difficult in some cases, and also to wire in and put in the fixed condition systems in themselves disruptive. There's a barrier as well in terms of skills. A lot of the systems that have been put in have been very highly complex, relying on significant interpretation of data, allowing for those individuals that are in the factory to look at that, compared to the other issues that they may be dealing with around reactive. So it's not their focus. And also we're finding that the skills required with the aging workforce, a lot of those skills are retiring. The people that got those skills are retiring. So we're getting this loss of expertise. And literally recently now we're starting to get a lot more interest from the from companies to improve training. That may not be the case for your business, but in general across UK and some of Europe that is the case. And then also finally, the more difficult one to address, and certainly not one that we will be discussing today in any detail, but one that we can discuss with you, is the culture, where a culture of where reactive is rewarded, people who are heroes that get production up, rather than the line that just works, is just one that just churns out the stuff, is not the one from a maintenance perspective that's getting all the hurrah. And also there's a sense around the confidence in the technology. Really is this going to provide me with the with the insight that means that I can know when something's going to break or not. So that's what we think the barriers that have been stopping us so far. Now, to address those barriers, there's a few changes that have been happening. I'm just going to go through in terms of the technology, which then Alan is going to show a practical implementation of, so bear with us. But the key main thing that we have is this convergence, this thing called the Industrial Internet of Things. And the fact that we're getting convergence of technology between what is ubiquitous in the IT world and now what is happening in the operations technology world, the information technology and operations technology world. They're converging. And the consequence of that is the cost of technology into the industrial environment is reducing significantly. The cost of sensors, etc., are reducing. I just want to go through a few of the main technologies that are really reducing the barriers and explain how they are. The first thing is the connected assets themselves. One of the key points that we had was the CapEx cost of the assets. Well, with the number of assets now where machine connectivity and communication is being inbuilt into the core asset, because the OEM providers themselves see it as a way of themselves providing additional services to customers, is astounding. So basically OEMs are starting to ship assets with a rich array of sensors now, communicating through open and standardized protocols such as OPC UA and MQTT. So the people who are putting in for the new machines, they're getting in on the act. The second thing is, if you haven't got the new machines and you're looking at doing this stuff on a retrofit basis, there are plenty wireless sensors and protocols around. So wireless sensors with long battery life are available for a cost-effective retrofit is what we're trying to say. And those are such things as vibration, temperature, pressure, humidity, even down some health and safety ones around around air quality, etc., and even certain gases now in terms of wireless sensors. And what this does is significantly reduce the cost of installation, the affected downtime, and really changes the swings where the business case is. The next thing is that with compute, the edge gateways, and these are the sort of industrial small mini computers that can sit next to those sensors and those machines that have some compute locally that can run algorithms to identify if a machine is in trouble, looking at that locally. They're starting to become more ubiquitous and available. In fact, there is a plethora of them on the market. And they have got the connection and software on board now, which enables them to connect to any asset protocol and also these wireless sensors. Now that gives you the connection. The other thing that's sort of changing is the secure fast communication. So we've got new 4G, 5G networks with secure private access point names, so private APNs, providing access to cloud computing. We've got new industrial standards as well about machine connectivity and security, which are pretty much ensuring that the data that's coming from a machine and going to analysis elsewhere is very well supported. And then that brings us also to the industrial innovation platforms, something like PTC's product ThingWorks. These are platforms that enable us to wrap and extend what's going on in your factory and start to present the data in applications that are based on the roles. And one of the roles today we've been looking at will be this condition engineer. The other thing that's starting to happen as well, which is machine learning has been around for decades. And what's starting to help change now is that there are machine learning applications that automatically choose the right algorithm and can test their own predictions. So there are machine learning products now, like ThingWorks Analytics, where we can take data in and we can then start to predict failure. And there are other product companies as well, like Senseye, that are providing those types of services. And of course, we've got the ubiquitous HMIs, or phones, as my children call them. These human-machine interfaces, these handhelds, are now low cost and everywhere. We've also got industrial-grade tablets with IP ratings available, all at very much lower cost and much more available. And again, this is part of this IT/OT convergence that's there and available. And then finally as well, unfortunately, we're all getting used to this now, remote working. We're getting used to the idea that we don't have to see someone on site for them to be there and attentive and giving us attention. And also we've got ability now to for the remote worker to see what it is that you're looking at, and then they can give advice locally, and they can also augment, using augmented reality, the world that you're seeing to explain and draw on the world that's around you. So basically what we're trying to say there are those sort of four barriers that we had are being really addressed by this technology, with the exception of culture, which is really down to leadership and to the individuals there. And as I say, that's something for a separate topic. So without much further ado, I'd really like to introduce you now to Alan Findlay. Alan runs Drive Management Services, a part of Haley 247 and the Dexis Group. And I'd like to just hand over to Alan now to introduce himself, his business, and take us through real practical applications of how this change in technology is now being applied into some of his customer base. Alan.
Good afternoon. As John has mentioned, we are a key partner to InVMA, and we want to thank them for the opportunity to present on the Hidden Factory webinar series. My name is Alan Findlay, and I'm the Managing Director of Haley 24/7 Engineering Services Limited, trading as Drive Management Services, or DMS as everybody knows us. For those who don't know us, we're a reliability services business based just outside Sheffield, providing condition-based monitoring services and solutions for traditional industry sectors. Back in 2012, we recognised that the way we monitor assets was changing from conventional methods to those which are remote, interactive, and non-intrusive. As a developer of fixed continuous monitoring systems, we believe the future was based on providing a first-class diagnostic service via the internet or the web. So in 2017, we partnered with InVMA, the UK's leading ThingWorks integrator, to develop a truly flexible and dynamic IoT, or Internet of Things, solution called AssetMinder. The following 2.5-minute video demonstrates how our latest IoT platform delivers real benefits working with their machine guard Bluetooth technology sensors.
Introducing a revolutionary approach to condition-based monitoring. A system that has been designed, tested and refined over the past 20 years to offer a truly remarkable, cost-effective solution to virtually every industry sector. The Machine Guard solution has been developed to identify potential mechanical failure within critical assets, enabling you to take necessary action before any costly problems occur. Machine Guard's core technology, which originated in the highly specialized aerospace and Formula One motorsport environments, has helped save our clients literally millions of pounds in lost revenue due to unnecessary downtime. We work closely with every client to identify their critical assets and outline the best way to apply the Machine Guard solution. The easily installed gateway can accept data from a wide variety of sensor types, including our cutting-edge Bluetooth vibration and temperature sensors, suitable for use on any critical rotating or reciprocating equipment, including gearboxes, electric motors, fans, pumps, and much more. And because it's a wireless solution, installation is quick and efficient. Streamlined access means any internet-connected device can be used to monitor critical assets via the AssetMinder cloud-based platform, a powerful 24/7 managed monitoring system providing alerts that can be triggered using the format best suited to your business. From a single site to a global operation, Machine Guard, powered by AssetMinder, can provide the kind of all-encompassing protection your organization needs. Remotely identifying imbalance, misalignment, mechanical and structural looseness, bearing and gear damage, lubrication starvation, cavitation, and other potential issues. Welcome to the power of predictive maintenance.
As you've seen on this video, this is the future, but it's also here now. As an engineer of 40 years experience, I can't begin to tell you how delighted our site installation engineers are now that we have these Bluetooth accelerometers. It reduces our installation time by approximately 75%. No running cables in along existing cable runs, trying to identify tray width that is suitable. And finally, trying to install cables in locations that are difficult to access. The next two slides outline the basic capability of the Bluetooth sensors that we utilize in our Machine Guard hardware. As you can see from the bullet points, they can be installed in minutes, are rated to IP67 for harsh environments. The sensors come supplied with the capability of 3 modes. 1, continuous monitoring to a predetermined scheduled time. 2, wake up. It wakes up every so many seconds, assesses the vibration level, and if an alarm level hasn't been exceeded, switches itself back off, only alerting on exception. And 3, triggered manual wake up via a magnetic switch. They use ultra-low power and use replaceable batteries, utilizing Bluetooth version 5 for increased battery life. In your traditional industrial facilities, you can expect to collect data from 50 meters away. There are also 2 versions available, a non-hazardous and an ATEX hazardous. These Bluetooth accelerometers immediately display RMS velocity, RMS acceleration, peak-to-peak acceleration, temperature and battery life. The high-resolution FFT spectra can then be transferred on a predetermined time schedule. As you can see from the above specification, these accelerometers are supplying high-quality data that enables us to undertake a diagnostic service for our clients with real confidence. As part of the Machine Guard system, DMS utilise Dell Edge 3000 series gateways that can communicate directly with the Bluetooth accelerometers. Each gateway is installed with a roaming SIM card and a Soretta Tango 22A, GSM 3G and Wi-Fi antenna. These gateways are supplied in IP-rated stainless steel enclosures for protection and are capable of communicating with 200 off accelerometers and maybe more. We selected the Dell Edge 3000 series gateways based on their quality, supply chain, and more importantly, their mean time between failure performance. Each gateway is pre-configured to enable remote connectivity. Part of our reasoning behind the development of our IoT Asset Minda platform was to have a system that could deliver true machine health. Our vision was to have a true condition monitoring platform that could accept data and variables from all different types of sensors to enable us to assess condition, but more importantly, when diagnosing the equipment, become more prescriptive in our analysis. We have now this capability in our machine guard system when powered by Asset Minda. Currently, we can install additional sensors to the Bluetooth accelerometers, such as, but not exclusive, oil condition and oil temperature, pressure, flow, fuel density, speed, and much more. As part of our service, DMS have a team of diagnostic engineers based in our business who can access the data from any device, anywhere. All alerts generated by email, SMS text messages are immediately received by our clients' contacts and also by our own diagnostic engineers so that no issues are ever missed. This service enables us to react quickly and diagnose the problems at the onset. The simple access of the data from any devices ensures that both the client and us can discuss the same data and findings without being on site. The next section is based on 3 case studies that all display the capabilities of the hardware, system, and more importantly, the diagnostic service we provide. Case study number 1 is a critical stack fan located in the main process plant of one of our clients. The system was installed with us taking readings from both motor bearings in the radial plane, both fan bearings in the radial plane also, and an axle reading from these fan bearings. DMS will receive alerts regularly from the motor, so the DMS diagnostic engineer quickly identified by the velocity FFT that you can see on the screen that the motor was loose. The site engineers acted on our evaluation and found the 2 holding down bolts at the non-drive end of the motor were loose, and actually one had the nut missing. You can see the trend readings after the remedial work was completed on the right hand side. The second case study. Within the first month of our system being installed on this major critical process fan, we received a number of email alerts in acceleration on both the fan bearings. On completion of our analysis, we were able to advise the client that both fan bearings had significant wear and damage, which had been identified by the defect frequency for both the rolling elements and the cage. Unfortunately, because this is a 24-hour process plant, the next planned window for maintenance wasn't due to take place until the 2nd week in October 2019. As part of our service, we were asked to monitor on a daily basis and report to the client if these bearings deteriorated faster and quicker than anticipated. You can see from this slide how, together with the client, we managed to nurse these bearings until the planned change on the 9th of October 2019. Since this bearing change has taken place in October, the levels have stayed consistently lower and within agreed levels. Case study number 3. We were invited to work with a UK specialist fuel pumping station to help them monitor their critical multi-stage pumps. These pumps are unmanned and in a remote location. We installed 5 off ATEX Bluetooth accelerometers due to them pumping fuel and monitored them in the following positions: both motor bearings in the radial plane, non-drive end and drive end, and both pump bearings in the radial plane, drive side and non-drive side. and one final accelerometer on the axle position on the non-drive side. These can all be seen in the photographs on the right-hand side. Within 6 weeks of the original installation, we were receiving alerts on both RMS acceleration and peak-to-peak acceleration from both motor bearings. On analysing the FFT information from the Bluetooth accelerometers, we suggested to the client that we thought there was mechanical looseness, which was probably associated with significant wear on the white metal bearings, and as a consequence should be investigated on an urgent basis. Prior to the client removing this critical asset from service, they requested that they would like further confirmation of this suggested condition. We at DMS arranged for one of our CBM engineers to visit site and take a full set of readings using our machine-centric handheld vibration analyzer. After we had undertaken this handheld survey, we produced a separate report which confirmed the readings produced by our Bluetooth accelerometers. We could also see the same time waveform pattern on the right-hand side, produced by both the Bluetooth and the handheld analyzers, was identical, which is a classic example of component looseness. On receipt of this separate report, the asset was removed from service and delivered to a local independent engineering repair centre who specialise in motor and pump overhauls. On completion of their investigation, they generated a report which confirmed that all the white metal bearings in both the motor and the pump were significantly worn and had progressive loss of white metal in the loaded zone. This damage had also created secondary damage on the impeller hub locations, which were worn and scored, which had suggested that the hub had been rubbing against the bush. This was a fantastic result for both DMS and the client. These three examples prove without doubt the capability of the equipment and the quality of our service. We've created this next slide in an attempt to dispel the myth that fixed systems are not cost-effective. We've taken the costs associated with a simple system consisting of 6 accelerometers Bluetooth, installed and producing data every minute, and an FFT spectra every 6 hours. We have then compared that to the cost associated with a breakdown on a critical asset on a site. The above chart simply displays the number of lost production hours in one event that would enable you to achieve a payback in 12 months or less in the system in question. In our opinion, these are significant cost savings and prove without doubt return on investment can be quickly achieved when considering all aspects of a potential breakdown. So what are the benefits of using the DMS Asset Minda platform? We have remote system adjustment once installed using inbuilt Kepware and Ubuntu on the gateways. And this enables additional sensors to be added easily and quickly, and also to make amendments. All types of sensors can be monitored by our system, as previously stated: oil condition, oil temperature, particularly using the TAN Delta oil quality sensors, flow, pressure, running speed, ultrasound, fuel density. All this enables us to monitor the all-round condition and health of the machine, not being restricted by traditional condition monitoring sensors. So there are some significant benefits of using the DMS Asset Minda platform with the Bluetooth vibration accelerometers. 1, it's easy to install. 2, the ease of setup with the remote setting adjustment once it's been originally installed. The reduction of on-site installation labour. Excellent system analysis information to enable high-quality diagnostics. And remote diagnostic service from our specialised engineering reliability centres. So if we look at developments going forward that are here now, we now have technology that's available where we are now looking to integrate into the machine guard system. This is the starting process for machine learning, taking data from various parameters, as you can see the examples on the screen, and understanding what these certain operating conditions are considered to be when running normal. However, when a system starts to see a change or an anomaly, in near real time, we can start to use that information to determine what the alarm rules are and the settings. Machine learning enables us to start to build a predictive model based on historical data and comparing this to near as live data. This predictive model then enables us and our clients to make insightful decisions. This is known as a digital twin, as it is comparing the real live data from machine and comparing this to a model of a similar stroke identical machine in certain operating conditions. This makes our decision-making process smarter. This is the final slide that displays how we see maintenance engineering journey that will become more and more apparent in the forthcoming months and years. This is the stage that will enable us to automate some of the work of the condition-based monitoring engineer on an expert-type monitoring system, which will lead to the next step in achieving world-class performance. We take the data, we make a decision, and we have an action. So, to summarize, predictive and prescriptive maintenance is more cost-effective than reaction for critical assets. The historical barriers and obstacles restricting clients using this type of technologies are eradicated with the reduction in sensor, equipment, installation, and service costs. New sensor technologies such as the Bluetooth accelerometers are extremely powerful on the cutting, not bleeding edge of technology. They are accurate and deliver real, precise, and sensitive data. By integrating various types of sensors and using the asset's own sensors, we are able to understand the machinery health and avoid unplanned downtime. Our highly trained condition monitoring engineers are able to analyze the information and provide advice when it happens, not when they're on site. And the majority of condition analysis will be automated, reducing the number of false positives and negatives. Our offering is based around our service. The majority of our competition in the marketplace are equipment manufacturers, so they're more interested in selling equipment and do not have the same service ethics that comes as our own DNA. Our people are our strength. Highly qualified diagnostic engineers employed to support all our global clients. The case studies presented today demonstrate our highly developed IoT technology enables our people to deliver real quantifiable savings and results. This remote monitoring enables us all to be regularly in touch with our clients without necessarily being on site, but still delivering a real valued service. And as the technology develops further, we'll be able to implement machine learning on various machines that will provide machine health data far and beyond the traditional monitoring methods. Welcome to the power of true predictive maintenance. Thanks for listening. Do you have any questions?